Let's take a look at putting all of our exponent rules together as we simplify the following expression. Now, this expression involves both zeros as exponents, negative numbers, and positive numbers as exponents. And where do we begin? Well, there's lots of places to start. So let's see. First thing that I would do to simplify this expression is I would look, first of all, at our coefficients, 48 and 16. And I would start right there and simplify those first. So let's begin. We're going to simplify negative 48 over 16. And in fact, 16 goes into 48 3 times. So actually, that's going to leave us with a negative 3 over 1. And now we have some more things to do. Remember, we have a rule for zeros, namely, any variable to the 0th power equals 1, right? Let me just write that rule down. So for the 0 exponent, we have a rule that says that anything raised to the 0 power is equal to 1. That means that in the numerator, negative n to the 0th power is just 1. So that's negative 3 times 1. And also, m to the negative 2 to the 0th power is also equal to 1, so that means I have another 1 in the numerator. So the numerator is just negative 3 times 1 times 1. In other words, the numerator is just negative 3. And so now we can focus on the denominator. I have, on the denominator, let me rewrite what I have. I have n to the negative 2. I have negative m to the negative 7. And I have n to the negative 4. Let's start by putting those n's together first. All right, if I have two like powers, or two like bases that are being multiplied, what do I do with the powers? That brings us to that rule that says that if you have some base to a power multiplied to the same base raised to a different power, or the same power, but another power, I can put those two bases together by doing what? By adding our exponents. So when our bases are being multiplied, we add exponents. That means I can put n to the negative 2 and n to the negative 4 together by adding negative 2 plus negative 4, and that gives me n to the negative 6. What about that negative m to the negative 7? Well, let me just break that up and look at that as two different things. Notice, if I have negative m to the negative 7th power, I can actually think of that as negative 1 times m. That's what's inside my quantity, that negative. And so really, I have a negative 1 being raised to a negative 7th power, and I have an m being raised to the negative 7th power. So that's what's going to be inside my denominator. I'm going to have, in here for the negative m to the negative 7, I actually have a negative 1 to the negative 7 power, and I have an m to the negative 7 power. All right. So a couple more things we need to do because we're almost done, but we have a bunch of negative exponents in there, and we need to clear those negative exponents out. To clear out our negative exponents, we want to use the definition for negative exponents. So what is our definition for negative exponents? The definition for negative exponents says as follows. If I have any base to a negative exponent, I can convert that negative exponent into a positive exponent by inverting my base and making my exponent positive. In a similar fashion, if I have a base that has a negative exponent in the denominator, I can get that negative exponent and make it into a positive exponent by moving the base from the denominator up to the numerator, in other words, inverting it, and making my exponent positive. That's our definition for negative exponents. I want to apply that definition to what I have up here in my expression. Where do I have negative exponents? I have 3 negative exponents. I have a negative 6, I have a negative 7, and I have a negative 7. Those are the only exponents that have negative numbers in them. So I'm going to apply the rule. In fact, I'm going to look at the second rule, which says I can get rid of those negative exponents and turn them into positive exponents by bringing the bases up into the numerator. So let's go ahead and do that. I have negative 3 in the numerator, And now I'm going to bring up my n to the negative 6. And I'm going to bring him up, make him n, but make the exponent positive 6. The negative 1's going to come up, and so I'm going to have negative 1 not to the negative 7, but to the positive 7. And finally, the m is going to move up to the numerator, and that's going to become m to the positive 7. I see one more step to finish this problem, and that is what I need to do is I need to simplify this negative 1. Negative 1 to the 7th power means I'm taking negative 1 and multiplying it times itself 7 times, right? Negative 1 times negative 1 times negative 1, etc., etc., etc. And if I have negative 1 multiplied together an odd number of times, 7 times, negative 1 times negative 1 times negative 1, etc., that actually is going to equal negative 1, right? Because it's an odd number of negatives being multiplied. So that right there is negative 1. So I have a negative 1 being multiplied by a negative 3, and those two together are going to combine and give me positive 3, right? Negative 1 times negative 3 is positive 3, n to the 6th times m to the 7th. That's my final answer. If you have any questions, let me know. This one's a little tricky, especially that negative sign inside the quantity.